Welcome back again. Today what we have is series and parallel connection of. Can you imagine me? I not even put solar series and parallel connection of solar panels. Because I got a question from one of my students in the last video I posted concerning this, so I decided to elaborate more with this video. So when it comes to series connection, when I mean series, I mean like when you connect. What we use for calculations is open circuit voltage, which means the voltage when the panel is on no load. And as for this, open circuit voltage is 40.36, the amperage is 11.4, and the wattage is 370 watts. So in case you are looking for the label is always at the back of the panel. So any panel always comes with a label. So the one you will use is open circuit, short circuit, and then the maximum peak power for the panel. That's what you use for your calculation. This is another panel, and another panel, so that you not get confused. I just put plenty of them so that you will not get confused. This is another panel. Okay, this is the diagram of a series connection. I'm using a 200 watts, 39 volts and 10 amps panel. So with this illustration, we are just using 4 panels. So in series connection, it's just like connecting your negative to positive, negative to the next positive, negative to the next positive, then leaving you with one positive and one negative. So let's calculate how many voltage, how many amperage, and how many wattage this connection is going to give you. That's in series. Okay, voltage V will give us, in series, voltage increases while current remains constant. So with this, we say 39 plus 39 plus 39 plus 39. That's 39 in 4 places. 1, 2, 3, 4, giving us 39 times 4 times 4. This should be about 156, right? Okay, this is 156 volts. So the current I will give us, current remains constant, voltage increases while current remains constant. So as they all have a current of 10 amps, so the current remains constant, which is giving us 10 amps. Then the wattage, which is power, will be, in all cases, wattage always increases. So just like 200 into 4 places, that's 200 times 4, giving us about 800 watts. So whether you are connecting in series or connecting in parallel, wattage will always increase. Whether series or parallel, wattage will always increase. So this is it for series circuit. Voltage increases while current remains constant. As you can see in the calculation, voltage was multiplied by 4 places, giving us 156 volts while current remains constant, which is 10 amps. So coming to parallel connection, we have here current increases while voltage remains constant. It's just an inverse of series circuit. So having this as an example, we are just using 2 panels as an example of 200 watt, 39 volts and 10 amps. So voltage here, so coming to parallel connection, when we say parallel, that means the positive of the first panel will connect to the positive of the second panel. If there is a third panel, it will also connect to the same positive. If there is a fourth panel, the same thing. So if you are connecting it, you connect all positive and all negative. all positive will connect together while all negative will connect together. So that's why I have this drawing here. Positive, positive coming here, giving us a single positive. That's two of them will join, giving us a single positive. The same thing here, giving us a single negative. So with this, calculating the voltage for this, voltage increases, current increases while voltage remains constant. So the voltage here is 39 volts. So 39 volts will also give us 39 volts, because here we have current increases while voltage remains constant. So the voltage is constant. It's now the current I will now have to increase, because there are two panels in a parallel connection. So you have to add the volts, 10 plus 10, giving us 20 amps. Then coming to the wattage, as I said before, which is power, to be 200 times 2, because we have just in two of them, giving us a total of 4,000 watts. 400 watts, sorry. So in a parallel circuit, the current increases while the voltage remains constant, and in a series circuit the voltage increases while the current remains constant. But we also have a case of series and parallel circuit. That's when you have to do series first before doing a parallel circuit. So that one depends on your application. So for this example, I just drew 9 panels of 200 watts, 39 volts and 10 amps each. So as you can see, I've done the series already. So this, I connected all in series. I connected 3 series, 3 series, 3 series. So leaving us with this one, we will have 1 negative, 1 negative, 1 negative. So combining this in a parallel circuit, it will just be like joining all the 3 neutrals together, giving us a single negative. The same thing, joining all the positive together, giving us a single positive. So in this now, how will you calculate the positive, the voltage, the current and the wattage? This is a series and parallel circuit combined together. So let's start with calculating each and every one of the circuits separately. So we have 200 watts, 39 volts in series, 3 of them. So the V for this first 3 panel will be equals, in series we say voltage increases. So V will be 39 times 3. 39 times 3, giving us what's 39 times 3? Check out for me.
39 times 3.
117. 117 volts for these 3. Then the current I will give us 10, because current remains constant, while the wattage P, that's power, will give us 600 watts. So the same thing applicable to this and this. So we have 3117 volts, 10 amps and 600 watts. 117 volts, 10 amps and 600 watts. So the total wattage, let's start with voltage. So the total voltage in a parallel circuit, so it's just like making this thing, making the circuit more simpler. We can just say, you can just draw 3 panels of 600 watts of 117 volts, 600 watts and 10 amps. Same thing here, 600 watts and 10 amps. Same thing here, 117 volts, 600 watts and 10 amps. So this is your positive, this is your negative, positive, negative, positive, negative. So connecting them in parallel is positive to positive, positive to positive, giving us one big giant positive. The same thing with the negative. So let's just put a jumper here because they are not connecting. Another jumper, leaving us with one giant negative. So just this circuit that we have reduced to this for a more simpler explanation. So voltage here will be 117 volts because voltage remains constant in a parallel circuit. Current I will give us 10 plus 10 plus 10, giving us 30 amps. While the wattage P will give us 600 times 3, leaving us with this 1002, that's 1800 watts. So this now, if you are asked to decide an MPPT that can take these 9 panels of 200 watts, 39 volts and 10 amps each, so you can confidently go for a charge controller of 150 volts DC, because the highest voltage your panel can go is 117. So you can choose 150 volts DC. Then coming to the current, that's the amperage of the charge controller. Let's say choosing an 80 amps charge controller will be very okay for the system. And then let's say a panel that's a controller that can take up to 4000 watts of panel can do the job, in case if they want to add more panels to it. So a charge controller of 150 volts, 80 amps and 4000 watts can confidently take 9 panels of 200 watts, 39 volts and 10 amps each. So if there is any question or any contribution that you have, you can leave it in the comment section, or if there is any topic that you want us to elaborate more, you can also leave it on the comment.